Okay, we'll get started again. Our next speaker is Mirko Bunju from the Swedish University of Agricultural Sciences, where he'll be talking about neonicotinoids in tree foliage, a risk for aquatic organisms.
Yeah, thank you very much for the introduction, and a big thanks to all of you joining this meeting so early in the morning. I can imagine that was a long evening yesterday, and I very much appreciate that you nonetheless came to this session in the morning. So I think Nathan already did a very, very good job in introducing the basics of neonicotinoids, so I do not have to go into this. What I want to stress nonetheless is the fact that we are rarely looking into what is happening with the neonicotinoids based on their systemic nature. So their uptake in the plant and what is happening then. And we were interested in looking into what is happening with tree foliage when it enters aquatic ecosystems. And actually, this is the wrong version of the presentation. Anyways, this is actually what I wanted to go to next. So forget the slides in between. The idea of the whole project, Dominic, the main author of this presentation, is actually looking into is if we have trees that are treated in forestry with neonicotinoids to protect them from insect pest species, they can either be directly injected into the tree, trunk injection, or they can simply be sprayed on the ground and taken up with the water basically in the tree and distributed there in the foliage, right? And this is not necessarily only a theoretical exercise, particularly in the US. I think they are treating quite some trees with neonicotinoids in this way. So it's not only an academic question that I'm looking into, it has at least some applied angles as well. Now, as I said, taking up the substance in the trees, in the foliage, into the leaf litter, and during autumn, leaves usually tend to fall, enter the terrestrial ecosystem and then aquatic ecosystems. And as you can see on the bottom of the slide, this leaf material is then a kind of energy source for leaf-shredding organisms. They are fueling basically the whole heterotrophic food web in aquatic systems. And if the neonicotinoids are taken up, end up in the leaf material, and enter together with the leaf material the aquatic system, then we have two interesting, or a combination of exposure pathways that we are not necessarily very well considering during risk assessment, research, and whatsoever. And one is, of course, these neonicotinoids can simply leach out from the leaf material into the aquatic environment and induce a kind of a waterborne exposure pathway, just as we would assume when spraying these substances on agricultural fields, right? The other thing is, the organisms, as I said, the shredders are feeding on this leaf material, so they take this leaf material together with the contaminants potentially up, and that might induce some effects. Considering this and that the substances are relatively or very persistent actually in the plant material itself, this kind of consideration has some relevance for both pathways, for the leaching and the food uptake. The question now, or the applied question here is now, is it sufficient to simply focus on the waterborne exposure pathway, so the spray drift kind of things as displayed on the left-hand side here? Left? Yes, left. Or do we need to consider the food uptake as well? What we have been doing is we have been running some static experiments, just 7 days, using shredders as the test organism and using their feeding activity as a sublethal response variable. We used 3 different neonicotinoids that were either applied just to simulate spray drift by pipetting it into the water, or we have used leaf material from trees treated with different concentrations of these neonicotinoids during summer. And what we have then done is to build those response models with the response variable feeding rate and the water concentration that we find at the end of the experiment in the water phase. So basically, or coming back to these thoughts here, if the waterborne exposure pathway is the only one that is relevant on the right-hand side, these two dose response curves should overlap, right? So the EC50 value should be the same if we base it on the water concentration only. If it's not, so it's deviating, the EC50 value or the curves are deviating from each other, from these two scenarios, then there is something going on that we need to look further into. Again, we have done this with a range of shredders, actually only two, with a range of substances and with a range of concentrations for neonicotinoids in water and applied wire or applied to the trees and used the foliage from there. And what we have seen is the blue curve is with the waterborne exposure pathway. The red curve represents if we are introducing neonicotinoids together with the leaf material. And what we have seen is that the dose response curves shifts if we are using the combined exposure pathway with the leaf material, shifts from the right to the left. So the EC50 value is decreasing, toxicity is increasing, which means that the water concentration that we are actually measuring is not fully explaining the response of the organisms. There is some additional effect going on that we cannot explain only with the water concentration that we have been measuring, right? Is that logical? Okay, good. So, toxicity seems to be more with the combined exposure pathway. The question is now, when we have this combined exposure pathway, at least I would be interested to know how relevant is it? So is it more relevant the leaching part out of it, or is the actual uptake of this contaminant with the food the relevant pathway leading to these effects? And Dominic was doing a great experiment with this, at least I think it's a great one, where he wanted to disentangle these two effect pathways. And this was the tree nursery that he was using. So basically we really have grown small trees, Alnus glutinosa, black alder trees, in the backyards of the lab. So it's not where he is living, but this is the lab somewhere in Germany. And we have spiked these trees with different neonicotinoids. Here it's thiacloprid, and we used only a concentration of 0.6 grams of thiacloprid per width of the trunk, per centimeter width of the trunk at the breast height. So that is a kind of the concentration that you are usually applying, or that is recommended to be applied by the producer of the compounds. And with this leaf material, we have done a multifactorial or two-factorial test design. One was simply looking with the shredders again into their response in terms of feeding and different other variables when they were feeding on control leaf material, but the thiacloprid was able to leach from the leaf material into the water, but the organisms didn't have access to this leaf material. So we canceled out basically the uptake of the contaminant via food. Another system was to give them access to this leaf material, let them feed on it, generate at the same time also the waterborne exposure. So this is the combined situation that we had in the experiment before, right? Now the challenge was, how can we generate a system where they are only able to take up the contaminant via their food? I mean, the substances are leaching, irrespective whether you tell them don't, but they still do, right? So what have we done? We have used a flow-through system with an exchange rate of the beakers of roughly 40 volumes per day. So it's relatively large water volumes going through these systems. If you consider something like 200 milliliters per replicate and then 40 times this, just to make sure that there is no or relatively low concentrations of thiacloprid in the water, then there is a lot of water going to the wastewater treatment plant. But we can generate this treatment that we want to see, namely that they are only or mainly experiencing thiacloprid exposure, neonicotinoid exposure via the consumption of this contaminated leaf material. Does that make sense what I'm saying? Yeah, good. So these are the three systems that we used. Of course, we had to set up a control system, and given that we are or were planning with the flow-through system on the right-hand side, we had to set up a control system there as well, just to relate the effects we see in the flow-through system to something that is really relatively close to the contamination environment and not to get some kind of artifacts in our assessment. We have done this for 3 weeks. I'm always saying we, it was Dominic. He was doing it for 3 weeks, water exchanges for the semi-static test design every week, new food every week, and he was looking into different variables. And given the time restrictions here, 12 minutes are very tough. I'm not going into every single one here, so I basically decided to cancel out the tiacloprid body burden because there was anyway nothing happening among treatments, so that's a kind of a boring story there. So what happened with survival? Basically, if we are separating these different exposure pathways and look only into the waterborne exposure thing, there is not much happening relative to the control. It's maybe one organism died or so, more relative in the treatment relative to the control. If we are only looking into the dietary exposure pathway, the same, there is not much happening. But survival goes down, not substantially, but 20% to some extent down as soon as we are combining both exposure pathways. So that means also here, looking only in one exposure pathway might be a little bit misleading, let's say it in this way. Let's look into the sublethal effects, leaf consumption. By the way, I forgot to tell you that the dashed line always represents the control levels that we have. Sorry. Looking here into what is happening with the waterborne exposure pathway, we see that they are feeding a little less relative to the control, a decrease of roughly 25%. The same is actually happening if they are only experiencing the exposure via the uptake through their food. If we combine both, it's again a little bit more. It's not that it's absolutely through the roof, but I would say the effect size is increasing from roughly 25% to 30–40%. So also there is something happening. So if ignoring one exposure pathway makes it a little difficult. We have also been looking into what is happening with their lipids, so their energy reserves over these 3 weeks to see, is there anything potentially happening with their potential to reproduce, to grow, to fulfill basically their life history, or to continue with their life history strategy. And what we have been seeing here, that there is also a kind of a decrease happening. It's not very much, so we see a reduction of 20% in lipid contents, which also already means there is something happening in the physiological reaction or in the physiological level of these organisms. So also here we see both exposure pathways are inducing roughly the same effect size. One is not statistically significant, yes, but the effect size is roughly comparable. Looking at the combined situation, it's again a little bit more happening here relative to the individual pathways, but again, it's not very substantial. It adds maybe another 5, 6, 7% to the effect size. So, and what I actually wanted to say in these 12 minutes that I had, and I could have simply put this slide on, is that we have, if we want to do our risk consideration of insecticides in general more properly, we should include tree foliage in our assessments. Both exposure pathways are relevant, although they are inducing only roughly the same effect size. In combination, they can be much more significant. And this is again not the final slide that I wanted to have. I have uploaded 3 different versions, and it seems that the first version is on here. I apologize for this. With this, and I'm still on time, that is at least what the watch here tells me, I want to thank you for your attention. I hope it was not too confusing. Thank a lot of people for their involvement in these experiments. The funding was also allowing us at least to do something, so also this is acknowledged here. And of course, thank you for organizing this whole thing here, putting your time into this. And now I'm open for any questions that you might have. No, not Erin.
Hi, thank you for your presentation, by the way. I had a quick question regarding the survival results that you noticed. So it looked like for the dietary treatment, it seemed like there was an increase in survival with that treatment compared to the control. I'm wondering if you had any idea what could have been leading to that, whether it just be natural variability or if there was some kind of mechanism that was increasing survival.
It is probably just one organism that makes the difference here. But you're right, they are surviving at least better. There is no reproduction going on. That is one important aspect. I think it's just natural variation. Actually, it should have been in an ideal world on the dashed line. Sadly, we are not in an ideal world. Yeah. So I would assume it's natural variation. Yeah. Aaron?
I don't need a microphone.
You do.
So you mentioned, I missed the first part of your talk, so the leaf discs, were they from living leaves, or are they like the fall foliage that we typically have fall in the stream?
Again, use the microphone, please.
So the leaf foliage, the leaf discs that you took, was that with live foliage, or is that your fall drop? And is there a difference between the two levels of the neonics in those leaf material?
So what do you mean with fall dry?
Well, because if you're a shredder, that's in the fall, the leaves fall into the river and they're going to consume them. But if you're using living leaves, a lot of living leaves don't fall into streams, so you're looking at like the fall.
Okay, now I get it, yeah.
So,
the leaves were taken at the time of abscission, so that means during leaf fall in October, they were taken from the trees.
Okay. Cool.
Yeah? Good.
One more quick one.
I was just a little confused about how you would calculate the dose levels, the exposure levels, like in a combined, you have a combined exposure, because you have a concentration in a leaf that's like, I don't know, nanograms per gram, and a concentration in water that's nanograms per liter, and what concentration units are you using?
So what we have done here with this dose response thing is simply to base it on the water concentration. Not what is happening or what is still in the leaf. We know what is still in the leaf after 1 week or so. We have some data, but I have it not in. I have it somewhere very, very in the back of my head. But I can look it up. So here the concentrations are based on what we find in the water. The other experiment, this factorial design experiment, the concentrations that I was showing are simply those that have been applied to the tree. So the nominal concentrations, basically. Also here we know what is in the trees, or what is at least in the leaves. We know what was leaching out over time in the water. I do not have the data in mind, but I can look it up there. So it is not a single matrix you can link basically to. That would be difficult. Does that answer the question a little bit at least? Yeah? Okay, good. We are done?
Yep.
Thank you so
Thanks
much.